Good morning to all. This is lesson 2-5, day 1, ellipses, and here are your notes for today. All right, so we're going to go ahead and start with a warm-up. This is 2.5, day 1 warm-up. The question says, complete the square to find the center and radius of the circle if the following. Okay, so in order to do this, first of all, you have a 0, so we don't move anything over. We are going to put our x's together, so x squared minus 8x plus a blank. That's a plus. Combine our y's together. Y squared plus 6y plus a blank equals 0. As always, we cut this in half. So half of negative 8 is negative 4. And you're going to square it, which is positive 16. What you do to one side, you do to the other side. Half of 6 is 3 squared, which is positive 9. We are going to factor this out, and when we factor, we have x minus 4 squared plus y plus 3 squared equals 16 plus 9 is 25. You are not finished. The question says, what is the center? So our center is always the opposite. Opposite of negative 4 is positive 4. Opposite of positive 3 is negative 3. And your radius is the square root of 25, and the square root of 25 is 5. Okay? So your center is 4, negative 3, and your radius is 5. That is your warm-up for today. Let's look at our goal. Today's goal. Students will be able to write the equation and graph an ellipse. So what are we learning today? We're going to learn how to write an equation, and we are also going to learn to graph. So the first conic section that you guys learned was the circle. The second one is called an ellipse. Basically, it's a shape of an oval, and it is cut from this section right here, the oval section. Okay? This is what an ellipse is. An ellipse is a set of all points in a plane, the sum of whose distances from two fixed points is constant. These fixed points are called foci, singular focus. Okay? It's Latin. It's a neuter term in Latin. The origin is the center of your ellipse. So an ellipse is a set of all points in a plane, the sum of whose distances from two fixed points is constant. Constant means they're always the same. These 2 points, fixed points, are called foci. The origin is the center of the ellipse. All right. The equation of an ellipse whose x-intercepts are a and 0, and negative a, 0, and y-intercept is 0, b, 0, negative b, comes from the following. So you guys see how, look at that right there. Doesn't that look like a circle? Well, then when you add the other fixed point, the foci, that is how you get a ellipse, okay? Let me see if I can make that better. There we go, that's better. Okay. A circle is where a and b is constant. So if you really want to know, it's always x squared over 1 plus y squared over 1, and there's your r squared. Okay? So the a and the b is always the same according to the circle. So this here is like a circle squished, either stretch or compress. Let's read some real-life uses of ellipse. When a ray of light or sound emanating from one focus of the ellipse bounces off the ellipse, it passes through the other foci. This reflecting property is responsible for whispering gallery. So here's a gallery right here that you guys can see a lot better. And you can see how it just kind of bounce. Okay? So if I'm standing right here or right here, everybody can hear you. So kind of think about a room. Think about the Oval Office. Why is it called the Oval Office? From that point, the person can sit right here and listen to everything. That's why you were in the Oval Office. So now you have an idea why it's the Oval Office. John Quincy Adams was able to listen in on opponents' conversation because his desk was positioned at one of the foci beneath the oval, ellipsoidal ceiling, and his opponents were located across the room at the other focus. So, like this one, he's sitting right here. Here's his opponent, and he can hear everything because of the shape of the dome. Okay? Another example, the path of Earth and other planets around the sun are approximately ellipses. The sun is one foci, and a point in space is at the other. Did you guys see that? See how it forms that ellipse? Another example is an elliptical bicycle. Elliptical bicycle gears are designed to respond to the leg's natural strength and weaknesses. At the top and bottom of the power stroke, where the legs have the least leverage, the gear offers little resistance, but as the gear rotates, the resistance increases. This allows the legs to apply more power where it is most naturally available, which is up here. Did you guys see that? That's where most of the power is. Okay, as you can see, there's an elliptical shape right here, and the power is over here. So, to graph an ellipse, step number 1. Take the square root of the denominator, graph the positive and negative of that number. This is your x and your y intercept. Okay? So step 1. You take the square root of the denominator, graph the positive and negative of that number, and this is your x and y intercept. For example, okay, you have an equation right here. Okay? So notice how there's not any number with them. So your center is going to be 0, 0. So we're going to go to 0, 0. Okay? Now, here's your A. A squared is 49. So A is equal to plus or minus 7. See that right there? Notice this is under the x. X goes left and right. So I'm going to go 7 to the left. Before I start, I need to label 1, 2, 3, 4, 5. 1, 2, 3, 4, negative 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, negative 5. Always label your graph, okay? All right, so I'm going to go 7 from the center. There's that point. 7 to the left and to the right. Your B square is equal to 36. So B is equal to plus or minus 6. So I'm going to go up 6 and I'm going to go down 6. As you can see, here's the shape of your ellipse because the radius is not the same. Okay. I'm going to do my best to draw my ellipse. There's my ellipse, as best as I can. Alright, looks almost like a circle, but it's not because your radius is 6 from up and down and 7 left and right. Example number 2. Notice this is a plus sign. I want you to be aware of that as well. Okay, x goes left and right, y goes up and down. Okay? So let's look at example 2. Your center is 0, 0. A squared is 36, so A is plus or minus 6. B squared is 121, so B is plus or minus 11. Okay? So let's go ahead and graph. Here we go. Center, 0, 0. Left and right, 6. Oh, let me label my graph. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, negative 5. Negative 5. All right, here we go. So I'm going to go 6. Okay. And then I'm going to go 11. 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And here's my attempt to make a graph. Now notice this graph is more stretched. And there you have your graph. So as you can see, there's your graph. My computer keeps turning off. Okay, so do you guys see your elliptical? Kind of like an egg, isn't it? There you go. Okay, let's look at example 3. Here's another one. Okay? So what is your center? Center, there's no number with that x, there's no number with that y, so it's just 0, 0. A squared equals 4, so A is equal to plus or minus 2. B squared equals 25, so B is plus or minus 5. All right, so let me label 1, 2, 3, 4, 5. 1, 2, 3, 4, negative 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, negative 5. All righty. So we start at the center. I'm going to go out 2 and 2, up 5, down 5. I'm going to do it with my pencil. So when I mess up, my elliptical is not going to be so bad. So this is a stretch. There you go. All righty. And there's your example 3. All right. As with the graphs of functions and circles, the graphs of an ellipse may be shifted horizontally, left and right, or vertically, up and down. When this occurs, the top of the equation will change to indicate the shifted center point. For example, let's look at this example right here, okay? So, your center, just like a circle, is always opposite. Opposite of positive 4 is negative 4. Opposite of negative 1 is positive 1. So there's your center. Now let's take a look at your a squared. It's 16. See how it's under x is a. So a is equal to plus or minus 4. B squared is 36. So b is equal to plus or minus 6. Just like so. Okay? So let's go to your center. Oh, I got a label. 1, 2, 3, 4, 5. 1, 2, 3, 4. Negative 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. Negative 5. Always label. All right. So here we go. Negative 4, 1. So there's my center. From your center, I'm going to go out 4, left and right. 1, 2, 3, 4. 1, 2, 3, 4. This is your center. That's your main point. Your y, your b, I'm going to go up and down 6. 1, 2, 3, 4, 5, 6. Oh, right here. 1, 2, 3, 4, 5, 6. Okay? As you can see, you have a shape of an elliptical. And mine is not perfect, but just give it a curve. Make the best oval that you can. Okay? And there you have it. Example 3. Okay? In example 3, let's go ahead and label our graph first. 1, 2, 3, 4, 5. negative 5, 5, 1, 2, 3, 4, negative 5. All right, here we go. Center. Opposite of negative 2 is positive 2. Opposite of positive 3 is negative 3. Your a squared is 25. A goes left and right. Remember that? So a is equal to plus or minus 5. Your b goes up and down. So b squared is 49. B is plus or minus 7. You can do a decimal anytime. It's easier to graph with a decimal. All right. Your center is positive 2, negative 3. There's your center. From your center is where you move. A, left and right, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Your B up 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And there you have your somewhat a shape of an elliptical, if you will just connect them. As you can see, my oval is perfect, and so should yours. I'm kidding, I'm kidding. There you go. Alrighty? And so there you have your graph. Alright, so for your assignment is 2-5 practice. This one is due this Friday, 10/11/2019. Okay? This is when it's due. Alright. Have a good day.